let's look at how we can draw some octet exceptions and how you know there's an exception. So we'll start with this sulfur tetrafluoride, just like we normally would, different in the middle. And then let's count how many valence electrons. Sulfur is 6, fluorine is 7. That's 34 valence electrons that we need. So I'll start by putting them on the outside atoms first. This is where it's important that you always do the outside first. Okay, and then after I put all of those on, I have 2 left. So there's 32, I need 34. So I have 2 more. And I can see that sulfur already has 8, but it doesn't matter. When you have extra, you put them on the inside atom or the central atom. So this is that shape that we have that is a triangle. And the lone pair, I'm going to draw it on this side, has one straight up and one straight down. So it just has the one lone pair. And so for geometry, we would say, when we ask how many electron groups does it have? And so it does have 5. So the electron geometry is trigonal, bipyramidal, and the molecular geometry, when we're missing this one, remember on this one, the lone pairs are on the triangle. And so what's left is that shape that we called seesaw. It's kind of like this is the ground and here's the kids. But anyway. And then let's ask another question since we're here. Is this molecule polar? And it is. Let me redraw it a little bit. It's got so much stuff on there. It is. It's polar, and because if it had the same atom, if there were another fluorine out here, it would be nonpolar. But because it's not symmetric, it has one end that's different. This lone pair will be very negative, by the way. So this is polar. Okay, let's try another one. So the bottom line on this one is extra electrons go on the central atom. This one you just have to know this compound. You need to know that boron, particularly always, and boron trifluoride has 6 electrons. And so it's stable with just 6. So let's just go ahead and go through the steps. Boron in the center. We have boron has 3, fluorine, so that's 24 valence electrons. When I start putting them on, do the outside atoms first. And then I check and see. I've already put 24 on. So, because of this, so I've already put them all on. I might check boron and I see that it only has 6. But I need to know that that's okay. We're not going to make a double bond. Okay, so that is complete. And let's go ahead and go through our usual questions. How many electron groups? Well, there are 3. And what's the geometry when you have 3 electron groups? It's trigonal, planar. If you haven't figured it out yet, you need to have all these names memorized. And then the molecular geometry. So this one, trigonal planar, is where you have basically a flat triangle. And this one doesn't have any lone pairs, so the molecular geometry is the same. Okay, and what do you think about polarity on this one? It's very balanced. These are pretty polar bonds, but they balance each other. It doesn't have a positive and a negative end. If anything, it has, like, the outside is negative and the inside would be positive because fluorine is very electronegative. So, but this is nonpolar because it's balanced. They kind of cancel each other.